Hey everyone, welcome back. My name's Chris. This is Fully Defined and the SolidWorks by Lego Build and Learn series. Just a single part in this episode today. We're doing the main curved panel, which is the yellow one on the rear of the wheel loader. This single part has some non-straight geometry to it. Okay, so some edges that have a bit of a curve. So I go through a bit of a process of setting up the size and the shape of the part using some reference points. Of course, with Lego, there is a system in place that we can use to get some dimensions set for us. And then we just go through methodically one by one to add most of the details to the part and make sure we've got a good looking replica for our model. So let's jump in. So here's the part that we're going to be doing. This is the yellow panel. It is nearly symmetrical. We may do appearance labels later. Probably not going to do them at this point. So we can imagine without that. It's got this sort of consistent wall across here. It's got an edge on both sides. It's got a couple of small points here with some material taken out. These pin areas on both sides, they are to be sort of standard. You know, there's a small recess lip inside there, but on this side, there's a bit of a cut away, top and bottom. So we'll do that for both parts as well. Let's jump into it. Hello, internet, whoever is there. Now, tricky part. How does this fit into the assembly? Let's just have a look at that to see how we might go about modeling it. For that, I'm just going to have a look at the instruction, and I can see that it's positioned. If we even look at this picture here, it's on the left-hand side there, and that front face that we're looking at in this image here, this one goes straight up. So I think if we put the origin down at this pin here and use that as our sort of reference shape, that's going to match well with our assembly. So calipers I've got today, just back to the analog ones. Battery of the other one was no good. We're going to start on the right plane and we're going to draw this pin at the bottom. So that's got an outer diameter of 7.2, inner diameter 4.8, and we're going to try and get most of the geometry in this shape. So let me just zoom in on that part for us. Okay. So that has, look, at least the sides are flat. We'll do this later with an extrude, but they're flat across there. So that's neat. Why don't I put that other hole in, even though we don't know the exact position yet? So I'm just going to put another 2 circles over here on the right, make the inner and outer equal. And do I dare doing an X and Y dimension for this? You might have to. Wondering if there's probably a very standard dimension that's between those 2 points. If I eyeball it, it's going to be close to 30, 32, as in the same as let's have a look at an example. Yeah, reference parts. So we can use other parts here to give us a guide on how big it is. If I was to use this green one to line up that top hole, and then this black one to line up those bottom holes. And I think this is in the name of the file, the name of the part as well, where it says this one is a curved 3x5x3. So stud dimension, 3x5x3. But it comes down 4 studs. It's 5 across, 4 down, which would be 32 because we go in 8 mil increments. So 5, sorry, 8, 8, 8, 8. Yep, 32 and 3 high would be 24. Okay, that's what I really like about this system. Once you work out basic dimensions, it's easy to sort of join things together. So that's going to save me a lot of mucking around. Now we can put the front on. So the front is obviously tangent with this face here, which means it's coming up nice and straight from here. If I just draw it as a straight line, come on to that next. This bit is also tangent, so that comes off horizontally and then curves down. This one, whereas this face here has the very flat, this is the guide, very flat section. This one on the top side does not. You can see pretty quickly it starts curling away from that line. That means when I draw it here, I'm going to grab these tools. I'm going to bring that to tangents and then bring the height of this one up. Now, I'm going to use my radius measuring tools. Them there. Let me show you these. Here's a little kit that I got the inspiration for someone else on Bands or one of the 3D print places. I've printed a few little radius gauges. Okay, so R6, which means that's R6 and that's R6, and this can help me find
what that radius is on that top edge. So you can see it's bigger than that. Sorry, it's smaller. So it's probably around 3 millimeters. And what I can do is put this radius here and here. You can see that looks like a pretty good fit. So R4 for that fillet. Now, I don't need that till later, but what it helps me know is that the radius or the point here that I'm trying to sketch to is 4 millimeters away from where the curve is. I'm going to use that in a second. So R4, that's very handy to know. While I'm trying to estimate curves like this, what I'm doing is measuring, in this case, the flat section, and then using my eye, I'm going to where that curve intersection point is between the flat and the tangent curve on the top. And in this example, it's coming out about here. It's around 18 millimeters. So if I put this curve to 18, and then I put a 4 mil radius in, that's approximately the shape that I'm looking at with this part. We might do a 3D print later of this to see how accurate we are, but that's pretty good for now. What other detail do we want to get in this view? Probably not much. It's a good starting point to set us up for the model. I'm going to now do an extrude. I'm going to extrude these 2 pins either side, the round areas. I'm going to suggest they're going to be 8. They're right on 7.8 millimeters. So E for extrude for me, I'm going to select them, those contours. I am going to go one direction because this is almost symmetrical apart from the end. We'll do one whole side, all the detail, and then mirror the entire body. 4 millimeters, sorry, it's going to be 3.9 millimeters. Okay, let's do the rest of that. Let's do the rest of this shape now. Join those up. We're going to do a new sketch on the right plane. We're going to convert these edges, and we're going to look at the thickness of the main section. So not these edges, which are thicker, but the main section here. We'll do that edge afterwards. So to get the thickness of this main section, I'm going to assume that these edges, where it's a little bit thinner here, is consistent all the way through. So coming here, get my calipers. Now I'm getting about 1.4 millimeters. See on the other end, it's a little bit thicker, 1.5. So use 1.5. Offset 1.5, grab that edge, bring it down. Well, looking at the detail, I can see as well that this section, the section I'm drawing, starts a bit higher. It doesn't start right here where I've drawn it. It's definitely higher. What I can do for that, could measure this way, not almost. I think I'll go from the center point. Is it guidelines at 4 millimeters? It's going to be consistent. This one's got a bit of an angle to it, 4 millimeters. So the bottom one's easy. This one here, 4 millimeters from the origin. This one, so at this end, it's got we're going to assume it's vertical. It's so close. I'm just going to draw a vertical line and then dimension from that center. 4 is our shape. And then we've got our thickness, 23.8. So when we're doing something like this, we're only going half. We can put in 23.8 and then use formulas, in this case divided by 2, to get half the width. All right, another step done. So if we're looking at the joining detail, so in here we can see that there's a couple of ribs that are around out there, a bit of thickened plastic. This side's just one rib, do that later. If we look at this very edge, you can see there's a bit of plastic that continues from this circle, the tangency out, and goes into that plastic at the same thickness. And that's going to be consistent on both sides. So how that looks, we're going to, again, jump on the right plane. We're going to use the original sketch as reference. I'm going to convert that edge. I'm going to sketch down. I'm also going to convert the bottom edge and convert this circle and just use the trim tool to get the shape that I need, which is that section in between. Once I've done that for the top, also going to do that for the bottom. This is easier because it's all straight. So I convert those two, sketch that down, trim, and now I can extrude. I'm going to extrude up to surface, which is going to be this face. So that is doing that exact width, and it's going to merge all the bodies together now. Cool. Right, so now we can refine that join, so what it looks like, because we can see if we focus on this one, you can see the rib, but there's also plastic filling in. It's kind of flat, hard to see. The face here goes straight down to that, whereas this one, you can see at the moment we've got an undercut where there's this gap, a beam line undercut. See all this red section? That's currently an undercut. So in the real model that I've got in my hands, there's no undercut there. That plastic's filled in. Now we can fill that in the previous sketch. AMQ, welcome back. Feel free to drop in your question. So how I'm going to do this one, I'm going to extend point from here up and extend the converted edge down. I'm going to make those two tangents. And then you see that's fully defined, and that's going to fill in that area where there was an undercut. At the bottom, I'm going to do the same thing, but horizontal. So grab this point, put it across, trim around, through, and make tangent. And now that fills in those areas for me. So now if I look at undercut, well, there's no red section here. There's, yes, zero draft. That is something that would be changed in production, but no undercut there. While we're here, let's save this part. 24116. Good.
Hey guys, sorry to interrupt, but I'll try and keep this brief. If you're enjoying learning from me and would like to up your training in a more structured manner, you may want to consider taking my course on Udemy for SolidWorks for Designers, Foundations to CSWA. If we jump on here and take a quick look at the course, you can see it's pretty highly rated, 100 plus students so far. Only released the course earlier this year in 2025. We've got 7 hours of content. There's a huge range of learning resources attached to this, downloadable files, also examples of different projects, and everything here with the aim to not just get you to a certificate level, but give you some skills that you can take you to some employment as a designer or engineer. Thanks for letting me sponsor the video with this message. Let's get back into the content.
Okay, progress is good on this. Let's now should we do the rib? Yes, we'll do the rib on the bottom. I think that singular rib down here, we can measure that rib. It's on 1 millimeter. The size of the rib, estimate around 3 millimeters. On my right plane, we come and look. Yeah. Something like this, 3 by 2. And just going to extrude that up a millimeter. All right, that fills in that rib on that side. On the top side, there's 2 ribs and that round section there, which is the reverse of the injection point. Let's do the ribs first. Now these ribs, they are each a millimeter thick and they are combined 5.5 apart on the outside. So we're going to use that measurement to put them in. So what this looks like, I'm going to draw this shape. Now this one, I don't want to cut the angle. You're going to draw out, draw it down into here. MQ, you can try. I can open an image off screen, have a look at something. Okay, so I've got that section. Now that's down about 4 millimeters. And then that rib at the bottom, about 3 across. All right, now how we do this one, I said we're going out 5.5, and it's 1 millimeter thick. So 1 millimeter thickness. And then I'm going to go 5.5 divided by 2. And just make sure my direction is going the right way. And there's that rib. All right. Now the cut that I've talked about earlier, that's different in these two parts. It's on one side only. We don't put that detail in until we've already mirrored the body. So that comes later. All right. So next we do this wall on the side. For that one, you know, to sketch on the outer face, I'm going to hide the original sketch. I'm going to select tangency to convert that edge. And now this is where I can measure the thickness. So we can see at the end, it's got a consistent thickness across this edge, but then when it gets to the end, it tapers off, so it gets thinner. And here it's got like a flat edge and it gets thinner. So the main thickness is 3 millimeters. At the end, it's just under 2. This end, right on 2, just about 3. Okay. So what we'll do is offset this 3 millimeters inside. Then here, we're going to go across 2 millimeters, then up, and we're going to go up. What we estimate here is 6, trim that section. And then at this end, we're going to come down 2 millimeters. Now this one, again, it's got a flat section there, but it's a lot more subtle. I think what we'll do is the same dimension, 6 millimeters trim. So then we have our edge. If we measure the thickness of that edge, it's 2 millimeters. I'm going to extrude, make that 2, reverse direction, and okay, we've got that detail. So we're nearly there. All right, back to the part. Now we've done most of the detail, the injection point on the top, because it's quite visible. I think we should do that detail. So let's put that in. We can measure a diameter for that, 4 millimeters. The depth, I'm just going to guess. It's quite a kind of difficult position. It's also pointing at an angle. The center point of that is roughly 7 millimeters off that circle. So I'll show you how I do this detail. That is a construction line. I'm going to do a 3-point center rectangle like this. I'm going to put the middle of the rectangle on the edge. I'm going to do a line from the center point to the bottom. I'm going to do a line from the middle to the side. I'm going to make this is all construction. It's all just setting it up. And there are multiple ways of doing this. But I'm just trying to get an edge. I'm trying to get a box which is going to match, the alignment of that top edge. Because what I said is that from this point here to this point, looks like about 7 millimeters. I don't actually need the line. I'll just use that center point. What I can do now is use this as a depth guide. So let's say I think the depth of that groove is about 0.5 of a millimeter, and the width of it, we measured 4 millimeters. Put these dimensions in. 4. All right, now I'm going to do it's rounded at the bottom. There's a couple ways of doing that. I'm going to do that with the dome afterwards. So all I'm going to do here is use the construction geometry I've created to create a rectangle that's matching those, and do a revolve cut like this. And then in the bottom of the revolve cut, this is the part I'm not sure it's going to work because I've only got a semicircle. But I want to do a dome. Don't think it's going to work on a half size. So I think I'm better off putting that into the revolve cut. And to do that, I'm just going to grab this tool. I'm doing an arc. I'm putting the arc in line with this construction line, making sure this comes down and this joins up. And the depth of that, 0.4, change that to for construction. All right, now the dome is in that cut. All right, neat little tool trick there to get that detail. What we want to do on the reverse side is, now see that bump? I'm going to get something like that in there. So a very simple way of doing that usually is to offset that face to whatever thickness. Now does it go through the ribs? It does, right? You can see that detail. Let me just go big here for you. So just looking at this detail, we can see that the disc, this bolt goes through that rib. And so now if you have a look at my CAD where I'm doing this surface offset and I bump that up, that's also going to go through the rib. 1.5 mil would indicate pretty similar to the thickness that we did for this main section, 1.5 mil. So I can grab that surface offset and do a thicken. Just want to thicken it down to 1.5. All right. So it kind of worked. Can I delete this face to remove undercut? No, not quite. All right, back to this detail. So what I want to do now is work out a better way of getting this round section without having that undercut. Another way I could try and do it is to offset this surface here at 0 and then use that one to thicken up. I think it's going to create the same detail. Yeah. How can I change it? I could go bigger and then do another filler on that top edge. That's probably the easiest way of doing it. So delete these ones that I've done here. Grab this one, do a fillet, 0.5. I think that's pretty neat solution that puts in this dome section for us. It's not perfect. Actually, that's probably the way to do it. Yeah, let's do a surface offset, but include, I want to go 1.5, but include that face. There we go. Now it moves all the way out. How can I do this more easily? Let's bring it back down to 0. Do the same thicken. Good. I have to just delete the faces on this side here, which I can do, but I will no longer need that fillet. That goes. And I can grab these edges and do a delete face like this. Cool. All right, that's pretty neat. All right. Other detail on this part. We've got these sort of little cutaway areas on the sides here. These bits. Now, I am not 100% sure what they're there for. Normally, I might say like boring, removing some thickness from the material, but they're so thin. Don't know about them. I don't think there's actually any value of me putting them in this model. So we'll skip that. It's got a couple of fillets. So it's got a little radius here. Put that in. So that's at the tall edge up here. So I put a 1 millimeter there. I think it'll have the same at the other end. And again, put that in. It could even be a bit bigger, 1.5. And then on the outside, we have that normal sort of cut detail where it steps down. So we're going to do that. That wall, it's a 0.5 millimeter wall, I believe. So on this face, going to do 6, leave it 6, 2 sketches, extrude cut 0.5 millimeter, I think. We might have to tweak that later. It might be more, 0.8. we'll see. All right, so I think we're at the part to mirror this, at the point to mirror. So I select the face, select mirror, select body, merge, and okay. It's looking good. This part's looking a little bit deep than it should. So I'm going to reduce this thickness. It's still okay. And now we can do a cut. So the cut I'm referring to is when we look at this part, turn it over. On this side here, there's a cut away down this side. And that cut makes this side, the thickness of this only 7 millimeters. And the cut, as you can see here, it's like a semicircle, right? And it cuts away all that bottom material because it gets so thin from the wall. So all this section here, all of that thickness cut away. That's actually a way that we can measure the depth of that pin, because we can say, hey, the whole thing is 7.8, right? But without this side, it comes down to 7, which means, it's taken off 0.8 there. That cut is also 0.8. So we were right in that estimate. So the detail on the outside face, I think this is very easy, that we grab this edge here and we do a rectangle over the top, make that tangent, and do the same at the bottom, which is conveniently on the origin. Cool. Extrude cut up to surface, this face. There we go. Let's bring it into the assembly and give it the yellow color. Another piece. Tick off the list. You guys happy with that? Anyone watching? I think we got all the detail we need for that one.
I'd like to remind you that if you are having trouble with following any of the modeling, you can download any of the files by following the links in the description below. Once you've signed up to the email list, you'll get access to a Google Drive. In that drive, you can download either the SolidWorks 2023 version parts or step files. Step files can be imported to SolidWorks if you have a version that is older than 2023. Hey, thanks for watching all the way to the end. Really appreciate that. This has been the LEGO Build and Learn series by Fully Defined. If the next video has been released, it'll be on the top link to your right. Please hit the thumbs up and subscribe, and leave a comment below with what you'd like to see next. Your feedback is what motivates me to provide more content. See you in the next one.